Thank you for joining us today. You have had a whirlwind week because the New York Times did an extensive piece on the research you're doing and the center that you founded in 2009. Can you tell us a little bit about the center?
So what I attempted to do was to bring together clinicians, scientists, and patients at MIT. MIT is a premier engineering school. Engineers try to solve problems in society by bringing the best scientific advances through the lens of engineering. A lot of people at MIT have no idea what endometriosis is. So if I have a big center here that I invite people to come talk to us and see things in the lab, these really smart people learn about endometriosis and start to work on it and bring their new engineering brilliant minds to help us solve the problems.
So since you've done this in 2009 and here we are in 2021, what has been the difference when you first started to now? How has the awareness of endometriosis increased from what you've seen at a clinical level?
So I'm not a clinician, so I work with clinicians. I think the awareness of endometriosis among the general population, including my colleagues at MIT, has dramatically increased. The knowledge and awareness of endometriosis among my family, friends, anybody that you meet has dramatically increased. I think the Endometriosis Foundation of America has played a huge role in that. For myself, Padma's huge willingness to go public with her story when she did gave us the courage to be more out there with patient stories. So I think the awareness has increased at every level, the clinical levels, the scientific levels, and the public levels. One other thing though, adenomyosis, which is, you could consider the sibling, if not the twin of endometriosis, awareness about that is still needing to be increased. So as we have gotten the message out about endo, we also need to start bringing adeno along with it. That would be what I would say is a huge message.
Yes, April was just its awareness month too. And that was something I kept hearing is we don't have enough of awareness going on. So that's great that you're mentioning that. And Padma was also, I believe, a visiting scholar, correct?
So Padma has been a visiting scholar at MIT. There are lots of intersections between the science that we do in the lab and Padma's advocacy for nutrition and good eating. When she visited last, she visited the MIT Center for Gut Microbiome Informatics and Therapeutics run by my colleague, Eric Alm. And we had a lot of discussion about how what we eat changes our gut microbiome, and that influences immunology and aspects of endometriosis. So one of the research interests in our lab is we've built a model of the human gut using patient tissue. And we are hoping to connect that to a model of the endometrium and to endometriosis lesions with a little microfluidic circuit. So this is one of the things that we are hoping to do. It's not ready yet, but we've got all the people in the lab working on the various parts of it that need to come together. And so it was super fun to have Padma here to see what we're trying to invent to study the connection between what we eat and our endometriosis.
I was hoping that there wouldn't be a connection because I like my donuts and fast food.
Well, you know, everything in moderation.
Everything in moderation.
I grew up in the South and Krispy Kreme are near and dear to my heart.
You also have, I think your personal journey to this and where you have gotten is, to me, is very heartening because you were once a patient who felt gaslit in a doctor's office, was accused of, as the New York Times said, in quotes, rejecting your femininity when you were having symptoms of endo and were getting ignored, misdiagnosed, kind of pushed aside for years. Do you think that, I mean, there has to be a correlation, but what you went through trying to get a diagnosis has impacted your passion and your unyielding urge to try to find the answers to endo?
I think that, but really what pushed me over the edge was my niece, who grew up in Atlanta, is 30 years younger than me. And I had buried everything that happened to me until it happened to her exactly. She was shunted aside, sent for tests she didn't need. And when they came back negative, her female doctor told my sister, your daughter is making everything up to get out of going to school. 30 years after I'd gone through it, I mean, lava literally shot out of my head. I couldn't believe it. And so it wasn't so much my experience in itself, because I could chalk that up to, it was a long time ago. You know, I got sent home from school once for wearing pants to school because girls were supposed to wear dresses. You know, so I could say it was just the olden days, but it wasn't the olden days. It was the here and now. And that's really what got me to start working on endometriosis, was that, how can this be?
How can this be? And here we are.
And here we are.
And here we are. And the fact that we're still hearing these stories of people being told it's in their heads, getting misdiagnosed, usually 7 to 10 years on average. What are some of the findings, or at least some of the inklings to findings that you've come across right now in your years of research with this disease?
So I'll give you 2 key points of where I think we could bring special insights into the field, because I didn't want to come into the field, hey, I just want to do something, and I have to bring something that's new and important to the field. So as detailed in the article, right after I started working with Keith Isaacson, we got about $1 million foundation grant to start the center. And I was diagnosed with triple negative breast cancer. And this was devastating, of course, because your calendar becomes filled with doctor's appointments and chemo and so on. But it was actually really good scientifically, because within a day of finding and having a biopsy on my tumor, I knew that I was something called triple negative. So it was these 3 markers that they measured were molecular markers related to my disease status, the mechanism of disease, my prognosis, and my therapy hinged on these 3 markers. And everybody could kind of tell me, here's what you do. Here's all the studies that say, you know, what you do if you're triple negative. Unfortunately, it was a lot of chemo, but there was nothing like that for endometriosis. I mean, the state of the art for endometriosis was like, you know, if I'd been diagnosed and say, okay, your tumor, it's 3 centimeters. Here's what we're going to do. You know, you don't do that for breast cancer. You say the markers. So we first came in and asked, could we start to develop a molecular classification system for endometriosis? Because 10% of people have it. It's not likely one disease. So that was our big first insight. It's probably on a molecular level, not one disease, that all patients are going to respond the same way to all therapies. And we know that, right? Some women respond great to therapies that are birth control pills or other things, and others don't respond. So that was our first big contribution. And we did a study and we got a set of ways to think about it. It's not definitive because we only had about 100 patients. You need, 1,000, and you need other people to replicate it. But it was a start to get the field thinking, not just lesion burden, not just, how big is your lesion? How many did you have? But what are the molecular features of the lesions? And so this is what we brought. And we're still building on that. A second thing we did is we identified a potential new drug target, but pharma companies say, we want to know before we go into patients that it works and what patients are going to benefit. So this stimulated all of the development of the tissue engineering models, where we take patient biopsies and we grow them in the lab so that we can build tissue engineered and organs on chips models to test new drugs. And that's still sort of at an intermediate stage, but we're getting very close to being able to really test mechanisms of these different molecular networks patients have. So those, I think, are 2 big contributions that we've made. These are always very slow and painstaking. You've got to get funding, you've got to get the people, you've got to build something from scratch, but I'm very excited about the future.
Yeah, definitely. And endo itself, I believe in the article, they refer to it as similar to a cancer. Can you elaborate on exactly what that means? Because I've been hearing this kind of similar, people keep saying, oh, endo is like cancer, but it's not fatal. And what exactly does that mean?
So the journalist, who I have enormous respect for, made that analogy in a certain way in the article. And it does hold in certain ways, because some of the properties you see of a cancerous tumor, things like invasion, growth, attracting blood vessels, attracting immune cells, attracting nerves. These things are also characteristic of endometriosis lesions. So in molecular studies we've done, we find many similarities to cancerous processes. A big difference is the degree to which some of these things will happen and have breaks on them. So there are no what are called somatic mutations in endometriosis that drive the disease in a verifiable way. And so a somatic mutation, for example, is, I actually was on the front page of the New York Times 11 years ago because I had an ambiguous HER2 mutation. So HER2 is one of the three big markers. It's a growth factor gene, and it's often replicated many, many times or duplicated in certain cancers. And if you have a high duplication of that, and you can measure this various ways in the tumor, then you get a drug called Herceptin, which targets it. It's a really, really effective drug. And I was ambiguous for whether I had that mutation or not, and I had to decide whether to take the drug. So cancer often has mutations, and you can target the mutations with specific drugs to treat it. Endometriosis does not have those kind of driver mutations. So it's really chronic inflammatory disease like arthritis or Alzheimer's or type 2 diabetes. So your immune system is playing a huge role. Something drove it out of whack. And what we're trying to do is say, how can we fix the immune system so the immune system goes back into whack?
Because the immune system's almost having an over response.
Well, in some cases, it's an over response, and in some cases, it could be an under response. So it's an imbalance. It's sort of like, I find it very hard to lose weight by either just dieting or just exercising. They have to go together in a beautiful way. You do two things together. So I think we're still learning a lot about how the immune system, it's just not right. And it's not right probably in different ways in different people.
Right. So it does come down to being very individualized.
Mm-hmm.
Endo, what is your outlook for the future of the disease? Where do you think we could be in the next 20 years with it in terms of research?
So hopefully research will be done and everybody will just not have it. No.
I know, right?
You can say 20 years, of course, I dream like that. I think it's realistic to say where could we be in 5 years and 10 years might be something to think about. I think a very exciting thing to me is we're starting to learn a lot more about how our central nervous system, our brain, and then the nerves are interacting to influence the progress of the disease. And this is really important because some groups of patients may have gotten pathways in their brains kind of burned in to, and I'm being very, very simple here because I'm not the pain expert. There's a group at University of Michigan we're starting to work with on this. And I think that some imaging modalities for understanding how our brain is processing the pain and then going down the nerves, the molecular pathways from the spinal cord out to the lesions and the lesions interacting with the nerves. I think we're going to learn a huge amount about that in the coming 5 years. And I know that we're starting to build nerves into our models in culture. Yeah, and this is going to really change things because the advances in stem cell technologies and so on are going to make it possible for us to build a lot more complicated models of patients. And that's going to couple with how we can measure things from patients in the clinic. And so I think there's going to be some very exciting things. And this will couple with things about diet. So I think we're going to learn a lot more about nutrition, a lot more. And I think it's going to really get energized into some of the patients that will be taking up these new, we're going to learn some things. There's going to be experiments patients are going to do on their own, and we're going to learn from it because information is going back and forth between patients and researchers more easily now with all the apps and things.
Yeah, and knowledge is power and progress, and you're making a ton of progress for a disease that has been largely ignored for pretty much, we would say, the inception of the disease. And it's only been in the last 20 years that this is really becoming to the forefront. So I appreciate, as someone who has the disease, all that you are doing to move the needle forward. Thank you.
I appreciate that the Endometriosis Foundation of America puts such care into getting the word out to all kinds of audiences. It's very important what you're doing. So thank you for having me.
Thank you. And look forward to having you again soon.
Yes, likewise. Bye now.